Hello everyone, my name is Shao and from the Southwest Jiaotong University. My topic is robust operation for mental response using static model. My research mainly includes 4 parts. The first one is the introduction, 2. Static modeling, and 3. Mental response, robust operation, and 4. Results of Analyses. As we all know, the anti-rolling torsion device installed between the body and the bridge of the railway vertical. It is an important part of the second series suspense device, which plays an important role in the safety of the vehicle. From the Figure 1, we can find the contacting rod, torsion spring, supporting pedal, and torsion shaft. To improve the quality chapters, robust operation design is used to achieve the torsion's robustness through adjusting the control device variables and their tolerance. To evaluate the robustness of product quality chapters, a static model is established according to the static model process. The first product quality design quotation is the property of an satisfactory product as shown in equation 1. The second product quality design quotation is the sensitivity index, or expressed loss foundation, expressed as follows. From the equation, we can know that the equation 2 is the sensitivity index. The 3 is the loss foundation. The third product quality design quotation is the constant feasibility quotation, that is, the random constraints on other aspects of the product, raw materials, using conditions should meet the requirements. When random variables become worse, as expressed in equation 4. NSGA is a non-normal distribution or a constraint robust correlation. The conclusion formula can be expressed in equation 5. So, the static robust operation model is built according to the product quality design guidance and the boundary constraints, where X is design variables, XU and XL is the upper limits and the lower limits of design variables, respectively. Delta X is the mean total error of design variables. 3. Mental response robust operation. From the Figure 2, we can know the axis of force applied to a torsion bar. The contacting rod of vertical body is applied a lot through the upper robot joint. Then, torque is transmitted by the contacting rod and the torsion, and the torsion bar also subject to the load and the bending moment. According to the good torsion deformation and rebound chapters of the torsion shaft, its main working process is that the load is adjusted to meet the requirements of anti-rolling, while not affecting the variabilization characters such as hem, shaking, tail cropping, and nodding of the vertical. The specific parameters of the anti-rolling torsion device in a body of the vertical are as shown in Table 1. To achieve robust operation, we try to reduce the vibration and the error of the actual volume and the target volume of the anti-rolling torsion bus, volume or weight, stiffness, and 50 strings, so we can get the operating object formulation such as expressed in equation 7, equation 8, and equation 9, and we can get the operation constraints as shown in the equation 10, equation 11, equation 12, and equation 13. The last result of Analyses. From the Figure 3, we can know the flowchart of multi-response robust operation using the static model. We mainly use the Monte Carlo sampling static model combined with the NSGA is applied to promise statistical answers and the mental response operation. If the design variable internal is XLH delta X, XU separate delta X, and noise factor Z is a random variable that obeys the normal distribution, the robust operation solution of the static model as shown in Figure 4. From the Figure 4, we can find the robust operation solution and the general operation solution and find the difference from the two methods. Eventually, the probability distribution factors such as mean standard deviation, act of design variables, and noise variables could be obtained, as shown in Figure 4. And from the Figure 5, we can find the random distribution map of the Monte Carlo method. Next, we can get the operation results, and from the Table 2, we can get the operation results of terminal, geminal operation, and robust operation design. The results also show that the operation object volume of the torsion has been improved, and the statistical variations of the quality factors is reduced. We demonstrate that the promised solution cased by random factors is more stable and reliable, and then the robustness of the anti-rolling torsion bar eventually answered. So we can get three conclusions. The first one is a mental response robust operation method based on a static model containing the randomness of design parameters is promised. The Monte Carlo sampling statistical method combined with an NSGA Ⅱ is applied to solve the robust operation model to obtain a robust operation solution. The third is the robust operation case of the anti-rolling torsion device illustrates that the method is feasible and can be extended to robust operation with random multiple response in the product. That is all. If you have any question, you can email me or contact me. Thank you very much.